Hello everyone. I am Shumona. Today I am going to present I am Shumona. Today I am going to present our team project, that is the coronavirus tweet sentiment analysis. Basically, it's a classification project. So meet my team member Rishi, myself Shumana, Jitendra, Ankit and Mayank. Here is the project summary. From the summary, we can get an idea of the project. So COVID-19 pandemic got has shaken the every foundations of society, wherein the people were forced to live inside their houses because of the lockdown being imposed, and also the livelihood of the almost every section of the society was got impacted. So the objective of our analysis revolved around knowing the sentiment of people from their tweets on Twitter, as Twitter is one of the prime means of expression over social media. Here, so the project approach like text processing, exploratory data analysis, feature engineering and pre-processing, and finally the model training. So text classification with the help of a machine learning can be achieved using many of the ML algo like decision tree classifier, KNN, that is the K nearest level, SBM, multi-nominal Naives bias and Bernoulli's Naives bias, random forest stochastic gradient descent, like that. And here is my GitHub link. You can directly check that from here. The problem statement. This challenge ask us to build a classification model to predict the sentiment of COVID-19 tweet. The tweet has been pulled from Twitter and manually tagging has been done in. And in this data set comprises of 41,156 record, and which has 6 columns, namely location, tweet at, original tweet, sentiment, username, screen name, like that. In between the sentiment column, which tells about the inclinations of the tweet, and so it is our target variable here. And you can see that the image representation of the project, that is first step is the gathering and the labeling the data, that means is the collection of the data and data pre-processing. Next is text representation, and data pre-processing includes the lowercasing, removal of the punctuation, stop or removal, like that. And text representation is include the text lemmatization, vectorization, like that. And finally is the modeling by various type of ML algo like regression, logistic regression, decision tree, ML class, the name bias and the Bernoulli's name bias and stochastic gradient descent, like that. And final is the deployment of our project. So coming to our project part, for that we have to import some important libraries like NumPy, Phantom, and Plotleaf, and some modeling libraries also from the sklearn. Now we are mounted our drive for loading the database, and we are read the data set by using pt.read csv, and we name that variable name is data frame name is tweet. Now we check that first five rows of our data frame tweet, and by using dot head. And here we check the shape of the tweet, and you can see that tweet data frame having 41,157 row and 6 columns. And here is having the 6 columns are. And we also check the index, and to get the information about that tweet data frame, we check that tweet.info, and by that we get the what kind of data type having each column, any null values having or not. And we are also check the duplicate values, and by the result we get that no columns are not having any duplicated value. Again, we are checking the missing values or null values, and by using tweet.isna.sum, and from that we get that location column having 8,590, that much of null values. And again, we are checking that missing values and that location are having null values. Okay. So what did you know about your dataset? That from the dataset, you know that there are 6 columns, and the location column have duplicated value like 8590, which can take action later. Now now it's the time for understanding our variable. For that we again check the columns by dot columns, and that is to want to know the description about our data frame tweet. We use tweet or describe, and it will give the minimum maximum value, first quarter, second quarter, third quarter, and unique value of the 6 columns. Okay, the username stands by the column contain the username of the person who posted the tweet, and the screen name. This column contain the screen name or handle of the user who posted the tweet. And location means from where location the tweet was posted, and tweet at means from that which date that post was tweeted. And original tweet means this column contain the actual text of the tweet that was posted. And sentiment, this is the most vital column of our project. So this column contains the sentiment level assigned to the tweet. This level could be positive, negative, extremely positive, extremely negative, neutral, depending on the sentiment analysis algorithm used to classify the tweet. And to check the unique values of each 6 column, we are using the lambda function here. And you can see that unique values of the each 6 column. Now we check the sentiment columns of the tweet data frame uh, for checking the unique values of the sentiment, and we get that the sentiment column having neutral, positive, extremely negative, negative, extremely positive like values. And we also check the unique values of the location column of the tweet data frame, and we get that result. And you can see some of having not important values in that there. Now coming to the data visualization part, and for that we check the count of our sentiment, like positive having 11,422 that much of posted tweeted, and negative also having 9,917, like neutral, extremely positive, and extremely negative having that much of values. And we plot the proportion of statement versus count in a bar plot, and you can see that among all of the positive sentiments having most posted tweet. Now it's time. We are changing we are replace some of value like extremely negative into negative and extremely positive to positive for our better understanding part. Uh, and we are again counting that sentiment, and you can see that positive that sentiment are increasing from 11,422 to 8,046, because in the positive part extremely positives also added, and in the same way negative also increasing, and it is now 15,394. Now we are plotting the proportion of statement, that is the positive, negative, neutral into a pie plot. We are choosing the pie chart because in the pie chart we can represent the percentage value of the all the sentiment among the whole sentiment. So we can see the positive sentiment having 43.85%, negative also having 37.41, and neutral having 18.71. So you can see that positive was most tweeted. Now chart 3. We are created on chart 3, and for that we call the top location of tweet. That means from from which location the most tweet was posted, and you can see the London is the first among them, because 540 tweet was posted from London. So we are index, we are rename the index from location and location from location count, and we create a bar plot among them, and from the bar plot you can see London is the, and from the London most tweeted was posted. Now we are coming to our chart 4, and the chart 4 we calculate the length, that is the number of characters of each tweet, and store the result in a text length column. It is the text length column in the tweet data frame. Now We create a data frame named top tweet character length from the top character length. Now reset the index of top tweet character length and assign the result back to the top tweet character length. And we can see that original tweet row and tweet character count. That means in which row that total number of character count is showing here. And we plot that tweet character count versus original tweet row in a bar plot, and you can see that 25,160 rows having almost 350 words count. That is a row number 25,160 has highest tweet length of character, that is the 350. Now coming to the chart 5, and for the chart 5 we count the number of tweets for each unique date in the tweeted column of tweet, and you can see that first 15 date is shown here. And we again check that first 15 date of the date column of the tweet. For that we use dot head 15 inside the punctuation parenthesis. Sorry, inside the parenthesis we put the 15, and the result will give the first 15 date of the tweet. And here you can see 2020 March of 20, the most tweet was posted, that is the 3,448. And we plot that tweet date versus count. You can see and you can understand easily that in the 2020 March of the 20th, the most tweet was posted. And now we are coming to the most important part, that is the feature engineering and data pre-processing. In the feature engineering part, we handle the missing values or outliers, and in the data pre-processing part, we pre-process our text data. Here we are having the text data. So before modeling, we have to prepare our text data to and which column, which text not important for our modeling, that will be removed, and it will include that data stop word removal, punctuation removal, tokenizations of the word, like that task. And first the handling the missing value. For that we check the missing value by doit.isnal.sum.sort value and ascending equal to false, and it will give the result the locations having 8,590 null values. And here we can find that that location having that much of null values, and we generally not take location column as missing learning model analysis, because we thought that is not so much important for our modeling parts. And we handling the outliers, we did not treat it or handle the outlier because we did not take any column having continuous data, means not having any numerical data. So as a dependent or independent column during the model training. Now coming to the textual data pre-processing, for that we import NLTK. What is NLTK? Natural language test kit. And for that from nltk.corpus import stop word, and we have removed the URL token, and we have tokenized the word by nltk.word tokenized text, and we also remove the non-alphanumerical character, stop word, punctuation, and we lematize the word like that. Now coming to our create a new column named tweet called temporary list. In that list, we applying a lambda function here, and we split that clean tweet from the temporary list. And you can see the temporary list having that much of result, because you can see that all words are tokenized and lemmatized, and here are no having any punctuation, any white space, any URL that are not having. So it's now we are create a flattened list of all words in a nested list column. Now create a data frame of the top 30 most columns. That means top 30 columns which are frequently posted in the tweet, and you can see that coronavirus, that word are coming in the tweet in the 18,045 times. Okay, now creating a new data frame called neutral containing only the clean tweet column from the tweet where the sentiment column is neutral, positive and negative. You can see, and we call the positive and negative and the neutral. Okay, now we are creating an empty list called the spam corpus and iterate over each row in a data frame called to it where the sentiment column has the value of neutral, and you can see the top words from the neutral having like that, and we plot that uh, common words versus count. You can see coronavirus the most among them. Now we created the word cloud of neutral, positive and the negative also. Now it's time for that feature manipulation and selection, and it will include the splitting our data. First step is the splitting our data into the X and Y. X means the independent and Y means the dependent variable here. So in our project, X means clean tweet column, and we select the sentiment column for Y. And we applying the train test bit here, and here you can see the text size is 0.2. So data splitting ratio is 80% and used for training data and 20% used for test data. By providing more data for training, the model can learn more patterns and trends in the data, which can lead to better prediction on new or unseen data. Now we again check the shape of X-string and Y-test. You can see the 32,925 records are there in the X-string, and Y-test 8,232 record is there. And why we not select scaling our data? Because there no need of any scaling of data set, because here only check sentiment of people. Means we analyze only user sentiment according to the scenario of COVID-19. Now we check the information of the tweet, and you can see the data username column having integer type of data, location, and sentiment having object type of data. And no, here we decide that we used only two columns for machine learning modeling, that is original truth and sentiment in the both column equal number of rows. So we don't think the data set is imbalanced. For it's now time for ML model implementation, and for that we used count factorization. Count factorization is a process of converting a piece of text into a numerical format that can be used by machine learning algorithm. In this process, the text is first split into words or tokens, and then each token is counted to create a vector or number representing the frequency of each word in the text. And we for that we import from scalar of feature extraction dot text import count factorization and TF-IDF factorizer, and we used jag of words here, and we train that our extend by jag of words, and we get that the shape, its test shape is 8,232. Now first model with bag of what is the logistic regression. Logistic regression is a statistical model that probability of an event taking place by having the odds against winning range between 0 and 1 and multi-class classification for the event via linear combinations of one or more invariable. And first we analyze the logistic regression, that is by LRCB, and we give the penalty L1, L2, that is Las and Rich, and inverse of regularization strength, lower value, that is we selecting 110, 1.0, 0.1 and 0.01. Now we're creating gets a CV object with cross validation of 15. You can see CV is equal to 15, and fitting the training data to the gets a CV object to find the best hyperparameter. And we can see it's a CV is equal to 15 param grid like that, and penalties like that. And we predicted the value and predicted the linear regression CV is equal to like that, and we check the accuracy is 0.79, that is 79%, and we get the classification report And here you can see negative, neutral, and positive decision and recall, F1 score, and overall accuracy is there. Now we create a confusion matrix. In the confusion matrix, you can see the diagonal value is the true positive value. And so you can get a clear-cut idea of our sentiment. Here's the algorithm used logistic regression and accuracy of 79% and different evaluation matrix score with level negative, neutral, positive, like precision, recall, F1 score is also increased. Now, which parameter optimization technique have you used and why? Here we use the research CV used to tune two hyperparameter for the logistic regression. So here you can see from the logistic regression accuracy is 79%, precision is 77%. Recall is 77%, advanced score is 77%. Now we are comes into the email model 2, this is the decision tree classified with the CV. And in the decision tree, and we are initializing the decision tree classifier by DTCV. And we feel that extend wider in the DTCV and we predict the value and we check the accuracy in here 0.7. So you can see that in the logistic regression, the compared to the decision tree, accuracy is decreasing, that is 0.70, that is 70%. But in the logistic regression, we get the accuracy 79%. So we check for better accuracy, we use the name bias. In the name bias, we use the multinomial and the Bernoulli's name bias, and we attribute in MNB and BNB. We feed into the external and white in the MNB, that is a multi-nominal name bias, and from that we get the accuracy is 68%. So here also accuracy is decreasing, and precision is 68%, recall is 69%, and F1 score is 68%. For that, we again check the accuracy in the Bernoulli's name bias, and from the Bernoulli's name bias, we get the accuracy 0.69%. So here also some of improvement is there in the Bernoulli's name bias compared to the multinomial name bias. Now we for better for performance of the accuracy, we use the KNN, that is the K nearest neighbor. It is a simple algorithm that works by finding the K closest instances in the training data to a given input instance and then assigning the level of the majority class among those instances as the predicted level for the input instance. And we for that we input from sklearn.neighbor input K neighbors classifier, and from sklearn.model selection input create search CV, and we initialize the KNN classifier by KNN, and we are keeping the neighbors values here 1, 2, 3, 4, 5, 6, 7, 8, 9, and we perform grid search with 5-fold cross validation for the CV is equal to 5. Now feed the KNN model to training data and perform grid search and print the best hyperparameter and corresponding mean cross validation score. From the KNN, we get the accuracy 0.39. That means 39% accuracy we get from the KNN. That is the, I think, least among them. For that, we are using support vector machine for better accuracy, for getting better accuracy. And support vector machine is a algorithm that works by finding the hyperparameter that best separate the classes in the input data. And we initialize the model into SVM CV and fitting that to extend whiten, that is SVM CV.fit, and we predict SVM CV, and from the SVM we get accuracy is 0.76, that is 76% accuracy we get. So this is, I think, improvement is there in the accuracy. Now we also use the random forest. The random forest works by constructing multiple decision tree on randomly sampled subset of the training data, and each tree is trained on a different subset of the feature and the data, which helps to reduce overfitting and improve the generalization performance. And during prediction, the input instance is passed through each decision tree. and the majority vote among the prediction of the individual trees is taken as the final prediction. So we keep the random forest classifier here, and from the random forest classifier we get the accuracy is 0.76, that is 76% accuracy we get from the random forest classifier. Now we want to check also accuracy in the stochastic gradient descent. In a brief, stochastic gradient descent is instead of computing the gradient over the entire training set, the gradient is computed on a randomly selected subset, that is the mini batch of the training data. And this reduces the computational cost of the algo and imbalance enables faster convergence. The model parameters are updated after each mini batch and the process is repeated until convergence of a maximum or a maximum number of iteration is reached. So we used for that we import the some of libraries here and repeat the stochastic gradient descent, and we initialize before we initialize by SGD CLF, and from that stochastic gradient descent we get the accuracy 0.80. So it is the highest accuracy among all of the classifier, I think, until now. Now we also create the confusion matrix of the stochastic gradient descent. Okay, now we are using the TF-IDF vectorization. So TF-IDF vectorization means term frequency inverse document frequency, and for that we also splitting our data and check the shape of the extend and wide text before like that, and we vectorized the text. For that we import from sklearn.feature extraction the import from counter vectorizer TF-IDF vectorization. Here we are using TF-IDF vectorizer. And first we have checked the accuracy by logistic regression, and in the logistic regression of PF-IDF part we get the accuracy of 0.78, that is 78% accuracy we get. In the cross validation we get the 79, I think. Now we check the revision tree also, and in the revision tree we get the accuracy of 0.62, that is the 62% by the TF-IDF vectorizer. Now we check also name bias, that is the in the name bias multinomial we get the accuracy 65%, and Bernoulli's we get the accuracy 69%. Also we are used the KNN algo also. It is the K nearest neighbors, and from the K nearest neighbors we get the accuracy is very low. So you can see it's 0.27, that is 27% only. For that we also check in the accuracy in the random forest. In the random forest we get the accuracy 0.73, that is the 73% accuracy we get. And the last one we use the stochastic gradient descent, and by the stochastic gradient descent we get the accuracy 0.76, that is the 76% we get. Now by the use of support vector machine we get the accuracy is 0.77, that is the 77% on 77%. Here is the, you can see the precision of the 76% by the support vector machine. And classification metrics code. Classification metrics are used to evaluate the performance of the classification model by comparing the predicted level to the actual level. Accuracy can be useful in the evaluating the sentiment analysis model, particularly if the classes are imbalanced. That is accuracy, the proportion of correctly predicted level out of the total number of samples. That is TP plus TN by over all the TP, TN plus FP plus FM. That means TP means true positive, true negative, false positive, false negative. And by getting the overall accuracy of all the vectorizer we are used, that is count vector and IDF vectorizer, we get the series score here. And based on the metric chart above, we conclude that stochastic gradient descent modelizing count vector technique perform better with an accuracy level of 80% compared to logistic regression using TF-IDF vectorization, which achieved an accuracy level of 78%. Therefore, we have decided to deploy the stochastic gradient descent model using the count vectorization technique. And we are explaining the model which we have used and feature important using any model exercise tool, because the model has that we have used in stochastic gradient descent classifier, which is a linear classifier that uses gradient descent optimization to update the model parameter. The count vectorization technique works by counting the occurrence of each word in the text data and then creating a document term matrix where each row represents a document and each column represents word in the vocabulary. So to understand the future importance, we can use the permutation importance technique provided by the scikit-learn library. Now we can conclude that we applied 8 models, namely logistic regression with gates RCB, essentially classifier, stochastic gradient descent, KNN, SVM, multinomial, and the bundle snake bias for count vector and TF-IDF vectorization technique. So we conclude that the machine is generating the best result for the stochastic gradient descent count vectorizer model with an accuracy of 80.43%, followed by the logistic regression with gates RCB model with the accuracy of 78.86%. So in the future, we can repeat the analysis and compare it with the present sentiment analysis to gauge the impact of the initiative on the ground. Thanks.